Pre-calculus notes 9.3, polar and rectangular forms of equations. So today we're looking at converting things kind of back and forth is our big theme. So we got really comfortable with polar coordinates and how they work in 9.1, and now we're looking at converting points back and forth, converting equations back and forth between polar and rectangular. So first we're going to look at converting from polar to rectangular. That means I have r and theta, but I want to figure out my x and my y. So I don't know my x and I don't know my y. But I do have this r and I do have theta. So if I think about how I could do, well, for x, right, I could do cosine. So I could think about how the cosine of theta is going to be my x over my r side, so x over r. And then if I solve that for x, by multiplying both sides by r, I would have r cosine theta. And then I could do something similar for y. So I could look at how my sine of y, or my sine of theta, sorry, is my y over my r. And so if I solve for y, I would multiply both sides by r. So I have that y equals r sine theta. So now we have a way to convert. So if I want to find my x and my y, I can make that r cosine theta and r sine theta. So that's what we're going to practice here for example 1. So in example 1, we are going to find the rectangular coordinates because we have polar coordinates. And this does say -4, 45 degrees, so I want to go ahead and draw that. Let's see, actually I want to do this first. So I'm just going to write down that x is going to be r times my cosine of theta. So that means my x equals -4 times my cosine of 45 degrees. And that means I'm going to just draw a 45-degree angle. I don't have to actually plot -4, 45. So here's my 45. There's different versions of this, 1 square root of 2. We kind of decided we like that square root of 2, square root of 2, 2, but I haven't been using it much. So when I do my cosine of 45 degrees, I have root 2 over 2. So now I have -4 times square root of 2 over 2, which means I have -2 square roots of 2. And then I want to find my y as well. So y is going to be r sine theta. So that means -4 times, let's see, sine of, same thing, of 45 degrees, which is also root 2 over 2. And so I get that y equals -2 square roots of 2. So my rectangular coordinates are -2 square roots of 2, comma, -2 square roots of 2. So this is my rectangular point. So these 2 points would describe exactly that same spot. And it's not right here, right? This is just to find, oops, that was just to find my 45. So -4, 45, if I plotted that and I plotted -2 square roots of 2, comma, -2 square roots of 2, those would be at the same place. So now we want to look the other way around at converting from rectangular to polar. So that means I have x and y, but I want r. Well, that makes me right away, if I have 2 sides, my 2 legs on a right triangle, and I want to find the hypotenuse, we always go back to Pythagorean theorem. So I want to think about how x squared plus y squared equals r squared. So I can use that simplified version of Pythagorean theorem and say r equals the square root of x squared plus y squared. So we get that right away. And then if I want to have the angle and I only know my y and my x, so I could use tangent because y and x and my angle, those would all be related. So I could say that my tangent of theta equals y over x. And so theta is going to equal my tangent inverse of y over x. But the inverse only gives me answers in one quadrant. So I have to draw a picture and you might have to adjust to get the right quadrant. Because the answer that it gives you may not be the actual answer that you want. Because remember, when you do tangent inverse, it's just going to give you something between negative 90 and 90. So we might have to do a little bit of work. So make sure that we draw a picture when we're finding our angle. So when we start out with our xy, we would end up with square root of x squared plus y squared for our r, and then tangent inverse of y over x for our theta. So we're going to look at a couple of these. And this time around, I do mean 2 of these because these are a little bit trickier, especially depending on what quadrant we're in. So I always want to sketch when I am working with rectangular. And remember, we're trying to change these to polar. So I'm going to draw this one. And I have 2 and I have negative 4. And so first I'm going to find r. So r is going to be the square root of 2 squared plus negative 4 squared. So let's see. That's going to be square root of 4 plus 16, which is square root of 20, which is 2 square roots of 5. Okay. And then I know that my theta is going to be the tangent inverse of negative 4 over 2. So that means, let's see, theta is going to be, grabbing my calculator here, negative 1.11. And this is in radians, okay? I'm using radians right now. That's why I have such a weird number, and I'm not putting down a degree symbol. And I'm using radians because they're saying my angle should be between 0 and 2 pi. So let's go ahead and sketch out what we have so far. If I am thinking about radians, and negative angles here also. Here's my 0. Pi is 3.14. And then let's remember, maybe we'll go positive first. This would be half of pi, which is 1.57. And this would be 3/2 pi, which is 4.71. But a negative 1.11 is going to be down in here somewhere. This is going to be negative 1.11. So it does look like it's in the right quadrant. It looks like where I want it to be. So they're telling us to find 2 pairs of polar coordinates. And then I think the directions further go on to say one where r is negative, one where r is positive. One where r is negative, and one where r is positive. And we're not going to use negative angles for any of them. So if I want to figure out what this negative 1.11 is as a positive angle, then what I need to do is go over here, and I need to subtract it from 2 pi, because 2 pi would be all the way around. So I'm going to write down 2 pi minus 1.11, and that theta is going to be 5.17. So if I go all the way around and do that 5.17, and then the positive 2 square roots of 5, then that would be that point. So that's going to be my first one, 2 square roots of 5, and then 5.17. But I want a different one where my r is negative. So if I want one where my r is negative, that means I need to go to this line up here, basically instead. I need to go up to here, and then I need to go the backwards direction. So this is a straight line. And we know a straight line is 180 degrees, or in radians pi. So now I need to do pi minus 1.11. And that's going to give me 2.03. So that means if I'm looking at this angle here, maybe I should switch colors again. From this line here, and I want to go around, so this here and this here, that's going to be the 2.03. And then the negative direction, because it's going to be on the opposite side of that line, the opposite side of the pole. That would then be a negative 2 square roots of 5. So let's go ahead and write that down. So the other one could be negative 2 square roots of 5, and then the 2.03 instead. So we're keeping positive angles all the way through on this. That's kind of what they're looking for in our book, but we're doing one where the r is negative and one where the r is positive. So we are still playing around today with do we understand how these polar coordinates work? So the second one is really similar. We still have 2's and 4's. So we know that our r is going to equal 2 square roots of 5 again, right? And I know that my theta, I should still draw it, -2, -4. So my tangent of theta would be -4 over -2. So theta is going to equal tangent inverse of -4 over -2. So this time I'm just doing tangent inverse of 2. So that's going to be now a positive, when I do this on my calculator, 1.11. And so when I am writing down my ordered pair, my first one is going to be the, let's see, how do I want to do my first one? So I know that this 1.11 is not going to be this angle down here. So 1.11 is giving me this angle up here. If I want to go around and I want to be in that third quadrant, I'm going to have to add pi to that. So let's go ahead and do pi plus 1.11, and that is about 4.25. And so that means when I am looking at going all the way around to this line and then moving in that direction, that same direction, it's going to be positive. So I'd have 2 square roots of 5, comma 4.25. So when I am looking to make my angle negative, that's when I'm using the 1.11, right? Because I'm going to here and then I'm going opposite direction. So my other one will be -2 square roots of 5 and then 1.11. So that 1.11 gave me the r negative one. So there's a lot of crazy stuff on this. We really need to draw pictures every single time. You need to think about this. It might take multiple pictures. And we just need practice on this stuff, honestly. So looking at the next page, we're going to just look really quickly at some examples. In the picture, this has a radius of 3. So in polar, that's just r equals 3. In rectangular, it turns out that that is x squared plus y squared equals 3 squared, or x squared plus y squared equals 9. On the second one, the rectangular form is 2x minus 3y equals 6. So we've got an equation for a line. But in polar, it's r equals 6 all over 2 cosine theta minus 3 sine theta. So lots of crazy stuff going on. And what this is really showing is when I have something circular, like, oh my gosh, the polar is so much easier. If it's a line, it might be easier, it might not be. So if it's a line that goes right through that pole, right through my 0, then it's not too bad. But if it's any other kind of line, it's going to be a little more complicated. So first, to convert to polar, we substitute x with r cosine theta and y with r sine theta, and we simplify. So we're going to look at that here. So that means instead of my x, I am going to write r cosine theta. And then, of course, it's plus 2. And then squared plus my y squared is my r sine theta. And it still equals 4. And then I do need to go through and simplify. So when I square this, I would get r squared cosine squared theta. That's going to be squaring the first term. Then I'm going to multiply the two together and double. So 2 times r cosine theta doubled would be 4 r cosine theta. And then the 2 squared would be 4. And then r sine theta could be r squared sine squared theta. So I notice that there is a 4 on both sides. So I could go ahead and subtract those. And then there's something kind of interesting here. I think I'm going to look at what I've got left. I've got r squared cosine squared theta. And then I've got the, let's see, 4r cosine theta. So I'm remembering from before that if I have a cosine squared plus a sine squared, that it equals 1. So I'm going to move my r cosine theta to my 4r cosine theta to the opposite side. And then with these two that are left, I am going to factor out an r squared. And normally I would do this in a couple steps possibly, but we're out of space here. So I know that my cosine squared plus my sine squared of theta, those are just going to be a 1. So now I have r squared equals negative 4r cosine theta. And now I can divide both sides by r, and I have r equals negative 4 cosine theta. So now I've got that by itself. I know it says to graph it. You don't have to graph it. I'm not worried about you graphing the polar form. We knew it was a circle. It could still be a circle. If you want to use some kind of graphing program to do it, you can. To convert to rectangular form. So this is where there's a lot of different substitutions that can happen. And so we're going to look at a few different things that we could do. So here I've got theta equals pi over 4. So what I am going to do is I am going to take the tangent on both sides. And this is one of those where I'm just going to show you some magic tricks and some strategies, and then you're going to just try to apply them later. But these take just a lot of trial and error. So I am going to take the tangent on both sides because I can do that. Just like I can add 4 on both sides or divide both sides by 2. And then I want to find the tangent of pi over 4. So pi over 4, remember, is 45 degrees. So 1 square root of 2. So my tangent's 1 over 1. So my tangent is just 1. So I have my tangent theta equals 1. And then I know my tangent of theta is really just y over x. And then I can multiply both sides by x. And then I have y equals x. And it is a line. So in the last one, we could have written down circle. I think writing down the shape is kind of nice, but I'm not worried about the graphing. On the next one, where it says r equals 5, we're actually going to square both sides. So this is another hint. So we're going to just square both sides. R squared equals 25. And then where I have an r squared, I can substitute x squared plus y squared. And now we have the equation for a circle. So that one was a little bit easier. So options are taking a tangent on both sides. We use that tangent theta equals y over x. Lots of different substitutions we can make. The last one we're going to look at r equals 2 sine theta. So we are going to multiply both sides by r. So if you think about that circle one where we had to change it, there was that r squared and the r on the other side. So here we're going to start out by multiplying both sides by r. And then I know that my r squared, I can substitute for x squared plus y squared. We have that we can substitute. So I'm going to write down x squared plus y squared over here. And then for 2 r sine theta on that side, I know that y equals r sine theta. So on the right-hand side, I'm going to write 2 times y. And now I'm going to go through and get everything on one side. And then it looks like I have a circle, but I need to complete the square to get that in standard form. So y squared minus 2y plus 1 equals 0 plus 1. Because half of 2 is 1, 1 squared is 1. Oh, everything went away. Here we go. So then I'm going to have x squared plus, this will be the quantity y minus 1 squared, and then it's going to equal 1. So we had a circle again. And then here we completed the square. So the last example we did, these are the ones where you're really, it's going to take some playing around with it. Don't be afraid to get a hint or to ask for help or to work with somebody else on this.